So we'll continue with question 8 here in this video, number 14, I think. So a particle of weight W is pulled with constant velocity over rough horizontal ground. So a particle is being pulled over rough horizontal ground. We'll set it off in this direction. The pulling force has a magnitude of 5th W and makes an angle alpha with the ground. Okay, so again, the rope is over your shoulder. It's going up in that direction. And here's my ground parallel to the ground. So I have an alpha. And tan alpha is 5/12. 5/12, just so I can see it. So anytime I see tan alpha, I'll just always write it out there, opposite over adjacent, so 13. So cos alpha, 12/13, and sine alpha, 5/13. Just be careful not to make a silly mistake with these two. That could cost you vital marks for the rest of the question. So the 5th W is going in, I'll put W/5 is going in that direction. I have the weight of it is W, so I have W going down this way. I actually have WG, don't I? I'll just leave it at W now. I think they were told that the weight is W. And find the coefficient of friction. So we have mu r going in this direction. I have r going in this direction. So let's put in some values here. So I'll do another diagram. So here's my particle. If I have W/5 in that direction, and I have an A inside the triangle, I'm going to have in this direction, I'm going to have it's adjacent to alpha, so I'm going to have W/5 by the cos of alpha, which is equal to 12W/5, sorry, 12W/5 times 13, so 12W/65 is going in that direction. In this direction, I have W/5 opposite sine alpha, which is going to be, well, the 5's are going to cancel, so it's going to be W/13. And we're told the weight here, not the mass, so I'm going to have W going down this way. I'm going to have my reactionary force going up. I'm going to have my ground here and my mu r. Okay, so the forces that I have going on. So I have going up, I have r and W/13. So r plus W/13 has to be equal to what's going down, which is just W. So that would give me r to be, I've 12/13 plus 1/13, so it has to be 12W/13 to get it all the way up to 1. And we also have mu r is equal to this direction here, 12W/65. So if I fill in my r, I'm going to get mu times 12W/13 is equal to 12W/65. So dividing across by 12W first, I'm going to get mu/13 is equal to 1/65. So 65 mu is equal to 13. So mu is equal to 13/65. Mu is equal to 13/65, which works out evenly to be a 5th. And that's what we were asked to find here, the coefficient of friction. Okay, number 9. A particle of mass 10 is pulled over horizontal ground. So let's have a look at drawing some forces here. Particle Its mass is 10, so we've 10g. Is there an angle here? There is. So it's over your shoulder. We have our A. And the pulling force has a magnitude of 100 newtons. So I've got 100 newtons going in this direction. And then I'll need to get, if we have tan A is 3/4, opposite over adjacent, we can say that cos A is 4/5 and sine A is 3/5. I have my reaction going this way, and I have, do we have mu involved in this question? Normal reaction. The ground is smooth here. We smooth ground, and then we have the ground is rough. So here's my ground, it's smooth, and then it's rough. So there are the forces. Let's resolve them by doing another diagram. So I have 10g, which is 10 by 9.8, which is 98 newtons going down that way. And my reaction. Now, what about in this direction? Is the cos of A. So it's going to be 100 cos A in that direction, which is going to be, the cos of A is 4/5, so 100 cos A is 80 newtons in that direction. In this direction, we have this angle in here, A, which I'll put in here just to show you. From up above, we have sine, so it's 100 sine A, which is 60 newtons. So we can resolve, or we can find R here. You can see R plus 60 will have to be equal to 98. R plus 60 is equal to 98. My two ups have to be equal to my down. So R is going to be 38. And we are told, my resultant forces, well, there's only one going to the right, which is my 80N. So that's my F. So my 80 F is equal to MA. So we have its mass was 10. So 80 is equal to 10 times A. So my acceleration is 8 meters per second squared. So that's it when there's no mu involved. If there is mu involved, can we use the same diagram? If the mu is a half, if the coefficient of friction between the particle and the ground is a half, so let's have a look here. We have a half going this way. So what can we say mu R is? I'll take a shortcut here. Mu R is equal to a half by 38, which is equal to 19 newtons. So my resultant force is going to be the 80 going in that direction. And now we have something restricting us, 19 in that direction, 80. So we can see here 80 minus 19 is 61. That's my F. My resultant force is mass times acceleration. So 61 this time is the mass, which we had to be 10 times acceleration. So acceleration in this second part is 6.1 meters per second squared. So that's question, what are we on, 9? 8:45, we have 2 left. I'll do the last 2 in the next video, so to keep the videos nice and short.